All right, so when we last left this planet, Earth, it was a oblate ellipsoid. Now we're going to make it nice and round. Okay? The spherical planet that everyone loves. So we're kind of, just to refresh, we were going through the different shapes and sizes of the Earth's surface. Geoid, least used in GIS. Reference ellipsoid, the most used in GIS, but mainly for large-scale mapping. Like, if you want a number, I think like under 150,000, like 50,000 to 150,000, somewhere in there is like medium to large. Large being 24,000, if you think. But once you get out further into bigger areas like the southwestern part of the United States, or how about the Colorado River or the Nile, something that takes up long areas of land, we need to go to a spherical surface to do our mapping off of. So let's look at this. These numbers, did you like the lab last night? I think the second group liked it better than the first group, is what I heard. And did you survive? Yeah. Was it different? It's okay? Yeah. Okay. I like that lab. So when we take the Earth as a sphere, we do 40 million meters in circumference, right? 20 million meters if you go pole to pole. You don't have to write all these down. You can see I'm trying to get to something. 10 million meters from the equator to the pole. So, therefore, as I mentioned before, the definition of a meter is 1/10,000,000th the distance from the equator to the pole, and as a line of longitude running through Paris, France. And there they are. There's where the meter was created. That's what how big the meter used to be. So if you think of like colonialism, like Britain got time, right? They got the prime meridian. Well, France got weights and measures, in terms of legacy pieces. And I think I'd prefer the weights and measures myself and distances. Yes?
Is there a geographic definition here that's separate from this scientific?
That was the original definition, but what they found, and you can read Abler's history of measurement, what happened was that it was actually in air, that they sent two surveyors, one north and one south, out of Paris to do the survey, and the guy lied that went north. Didn't accurately document what he did. And basically what they found was, as they were going and doing the measurements, they found that the Earth wasn't round, that it was a geoid, basically, is what happened. So that the meter was an error, and that the measurements were in air, but they kind of covered up their tracks so that everybody thought they were great, and so that's partially why. And it's actually not literally, the meter itself is not this distance, which it is, just for your sake, but talking philosophy and history here. It's that bar of metal. I don't know what kind of metal it's made out of. It fits in between those two things. And then they store it in some vault somewhere. And then all these different countries, every country except for two in the world, follows the meter, right? You know the two? We don't. Actually, it's kind of cool if you're not from Tucson. The only interstate freeway that has the metric system on it is I-19 heading to Nogales, right out of Tucson. So we don't follow it, and Myanmar doesn't follow it. And everybody else does. But it's this made-up convention that we agree upon, that we're going to all bow to this metal bar. And then they found the metal bar was being degraded, and so they had to find another way to document the meter, and so they keep changing the definition. So to get something constant. One measure for all mankind. I can't remember the quote. Anyway, something like that. But the idea would be that it's not a human-based measure, that it was something based on the Earth, and therefore it would be objective, that people couldn't complain about it as much. It could transverse different cultures, but it's not true. Anywho, you can imagine that's why metrics works nicely, though, with mapping, because the numbers are constant and it is an actual measure of a spherical surfaced Earth.